Okay, so question 50 and 51. So 50 specifically says horizontal asymptote. And so if you want to know the horizontal asymptote of a rational function like this is one of those questions where you need to know the three different rules. If the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. If it was switched, it's y equals 0. And like question 50, if the degree of the numerator is equal to the degree of the denominator, it's y equals leading coefficient over leading coefficient. So in number 50, these two are the same. So it's going to be y equals 2 over 1, or y equals 2. You okay with that one? Okay, so horizontal asymptote, that's a way to describe the ends of the graph. It's the same as thinking about as x approaches infinity, or negative infinity, far left or far right of the graph. So the same skills that you used in 50 is what we're going to use in 51, with one little catch here. And number 51, I can't compare these degrees yet because this guy has a square root on it. And the square root of 4x squared minus 1, this is not like a perfect square or anything. But horizontal asymptotes are the far left or far right of the graph, like number 51 is asking, only cares about what's going on up here. Notice we didn't care about this plus x, minus 7, minus 1. It had no impact on the horizontal asymptote. Likewise, this, I mean, it affects the graph a little bit, but it doesn't affect what it eventually approaches. So what is the square root of 4x squared? Okay, so the important part is roughly 2x. Now we can compare these degrees. When the degree of the numerator is bigger than the degree of the denominator, you get no horizontal asymptote. So you could either say does not exist. That's what it would be most of the time. If it was a calculator question,
is it not infinity?
Well, but how do you know it's infinity? Okay, if we plug this in, you see how this number just keeps getting bigger. So this goes to infinity, and this number goes to infinity. But this number is going to infinity faster, so yeah, technically it goes to infinity. But a lot of times, well, most of the time it's going to be does not exist. Infinity and negative infinity are just numbers, or just ideas, they're not numbers. So does not exist is usually the way it's written. But if you had a calculator, I would suggest maybe graphing it, and then you should see why it's infinity instead of maybe does not exist. Far right of the graph, this guy's just going to keep going up. So that's why I believe the answer key says infinity. Infinity is slightly more specific, but without a graph there, that's a little harder to compute.